Algebra 1, Lesson 56. Part A is about sets, finite and infinite sets. Finite means there's a limit, like there's a specified number of items. A finite set has a finite number of members or elements. Okay, and so this is a countable number. There's an end. An example of a finite set, 1, 2, 3, 5. There are 4 elements or 4 members in that set. And we list sets inside braces like this. An infinite set has an infinite number of members. An infinite number of elements. Okay, and so an example of that could be the natural numbers. 1, 2, 3, 4, ... That indicates that it keeps going. It's called an ellipsis. And that just indicates that it keeps going, like you see a pattern here, and that pattern continues. 1, 2, 3, 4, 5, and so on. Okay, that is an infinite set. Right, that's all we're really going to say about those for now. Part B, membership in a set. Alright, so we see out here a bunch of numbers listed. You see sometimes some of the numbers are appearing more than once. When we represent these numbers as members of a set, we're just going to list them each once inside the braces. So we're supposed to call this set K. So K equals, and then we list these. It doesn't matter what order they're in. It's nice if they're in ascending order. So I'm going to write the lowest one first, work my way up. If I happen to miss one, it's no big deal. I can just add it in, because again, it doesn't have to be in ascending order. It's just nice. We have 0, 1, 2, 4, 5, and 7. Okay, and then a quick scan. Is there anything here that's not 0, 1, 2, 4, 5, 7? No, so that's it. That is set K. Alright, example 2, represent the following numbers as members of set L. So, L equals brace, and we have one negative, and then 0, and then I see a 1. 7, 8, 15, and 42. Make sure all these are on my list. Okay, that is set L. Alright, now we're getting a couple of new symbols down here. We'll label what they mean. In example 3, we have 3 different sets listed here. These are all finite sets. 4 elements in set A, 4 elements in set B, and 5 elements in set C. Alright, so this symbol right here means is an element of, is an element of, or is a member of. And that just means, is this number included in set A, for instance. So we look at set A. Is there a 5? Yes, this is a true statement. Okay, 4 is an element of C. So we look at set C. I don't see a 4 in there. That's false. Okay, now there's a slash through it, so not an element of. This says 5 is not in B. So we look here. That is true. There is no 5. Okay, so one more example. Okay, we have 3 new sets listed here. They're still all finite sets. Are the following statements true or false? Okay, 6 is an element of L. So we look at set L. I don't see a 6. That is false. 0 is an element of set N. Look at set N. There's a 0. That is true. And then here's not an element of again. So look at M. Set M. Is there an 8 in there? There is no 8. This says there's no 8, so it's true. Okay, that's all we need to do with those for now. Now in part C, we're graphing again. Okay, so in a previous lesson we have graphed linear equations, and in one even before that, you started solving an equation like this for a particular variable. All right, and when we're graphing, we always want to get the y by itself. That is, if you recall, the dependent variable. Y is going to depend on what x equals, so we get the y by itself. First step here is solve the equation for y. Always for y. Okay, so that means I'm going to subtract 3x from both sides. It's not a like term with that force. I didn't line them up. So here we have 2y equals negative 3x plus 4. Just get in the habit of putting the x term. Sorry. Hopefully this will refocus. Get in the habit of putting the x term before the constant. You'll thank me later. Alright, so negative 3x plus 4. Divide everything by the coefficient of y, because that's the one we're solving for. Y equals negative 3 halves x plus 2. Okay, now we can make our chart. So we'll be picking some x's, and then we'll be putting it in here, negative 3 halves x plus 2. Find out what that equals. We're going to need at least 3 of these. Okay, so here we go. I see whatever I choose for x is going to be multiplied by this fraction, which has a 2 in the denominator. So I want to choose even numbers for x so that I don't get fractions. So I think, and I also want to plan ahead, if I chose a negative 2, I'd be getting 5. That'll fit. I think I'm going to go ahead and just start with 0 now. 0, 2, and 4. Okay, they're all even. And 1, 2, 3, 4. That x will fit. So as long as the y's work out, this should work. So negative 3 halves times 0 plus 2. Negative 3 halves times 2 plus 2. Negative 3 halves times 4 plus 2. Okay, so 0 plus 2 is 2. Those 2's cancel. I have negative 3 plus 2 is negative 1. Okay, so that reduces. I have negative 6 plus 2 would be negative 4. Okay, these are going down 3 each time, so I have a pattern, which I want. Now, I graph these 0, 2. I didn't rewrite the coordinates, but I can get them from these two columns. 0, 2 is the first point. X is 0, y is 2. Okay, then 2, negative 1. X is 2, y is negative 1. Then 4, negative 4. X is 4, y is negative 4. And then I take my straight edge and make my graph. Oops. Okay, and there's my line. Now, any point 1 here, if I'd had that lined up a little better, any point 1 here should make this equation true. And it looks like it would have gone through right here. So I'm just checking this. 1, 2, 1, 2, 3, 4, 5. That's negative 2, 5. Okay, so if I put a negative 2 in here, that's saying I should get a 5. So negative 2 that's working. Okay, I'll just show you. Negative 2, negative 3 halves times negative 2, which I'm going to put over 1 this time, plus 2. Okay, those 2's cancel. I still have a negative times a negative. That's a positive 3 plus 2 equals 5. And that's also should be on my line if I line that up a little bit better. So I know my line is very likely good. I also know all these points were on that line. Anyway, just making the point that every single point on there, if I could tell you exactly what the coordinates were of this point, those values for x and y would make the equation true. Okay, so here's just one more example. We need the y by itself, so we'll add x to both sides. That's interesting. Y just equals x. So no matter what number I pick for x, y will be the same thing. So I will just do a t-chart for this one, because this is very simple. Okay, so if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. And I graph the points. 0, 0, 1, 1, 2, 2. And connect those points. You see we'll have a diagonal line going straight up through the origin here. And this one's going to end up being corner to corner. So that. Oops. There is my line for that one. And that is also the end of the notes.